Alright guys, welcome to part 2. Let's go ahead and finish up type 2 binary compounds, and then we'll get into the name of the covalent compounds. So we left off with copper 2 sulfate. The 2 right here tells you that copper is in a +2 state, so it has a +2 charge. Now for sulfate, I was being a little unfair to you because in regular or HL chemistry, we only briefly touched the polyatomic ions, okay? Polyatomic ion is an ion that's made of one or more types of elements, in this case SO4. We will discuss those in detail probably at the first week of school, and you will have a quiz on this like the second or third week. So sulfate has a -2 charge. I did not expect you to know that. If you did, you were already ahead of the game. So how are we going to write the formula for this one? Well, I know many of you are thinking to use the crisscross method, and you're exactly right. That's what we should do. So let's do the crisscross method. Let's just do the crisscross method. This is going to go down here. This 2 is going to go down here. So technically that means we have Cu2SO4 2. Now whenever you have a subscript for a polyatomic ion, you always put the 2 outside in parentheses. Now is this the right way to write this formula? You're probably going to say no, judging by the tone of my voice, and you would be correct. Even though mathematically it is correct, whenever the subscripts can be reduced, they should be, okay? The common factor between 2 and 2 is obviously 2. So this is going to reduce down to just CuSO4. And actually, I don't need that parenthesis. CuSO4. So in any situation where you can reduce the numbers down, you definitely should. There are going to be situations where this would have been Cu4SO4, and you would have had to reduce it down if we were doing an empirical formula. Okay. That's going to wrap it up for the type 2 binary compounds. Here's a couple of examples or exceptions down here that you need to be aware of. Zinc and silver, Zn and Ag, they are in the transition metal section of the periodic table. But let yourself not be fooled. Even though they are there, they do not behave like the rest of the transition metals. They don't get a Roman numeral when you make a binary compound out of it. So don't put a binary compound for something like zinc chloride or silver sulfide. They only will ever have one type of charge. The other exception is Sn, which is tin, and Pb, which is lead. SnPb, right here. Even though they are not in the transition metal section of the periodic table, they get Roman numerals. Their charges can vary, okay? So to reiterate, even though tin and lead are not in the center section here, they still get the Roman numerals. Even though zinc and silver are in the transition metal section, they do not get any Roman numerals. Now here's a funny little anecdote, a little story that my high school chemistry teacher taught me, and this is how I always remembered this, which ones get the Roman numerals and which ones don't. If you're in the transition metal block, we call that the Roman Empire. That means everybody in there gets a Roman numeral, with the exception of these guys down here. They don't get them. So if you're in the transition metal block, you are a citizen of the Roman Empire and you will get a Roman numeral. Except silver and zinc. They are spies in the Roman Empire. They don't get to be treated the same way. They are special. And because they are spies, they don't get Roman numerals. Tin and lead. These are citizens of the Roman Empire who are roaming outside of the Roman Empire. So they do get the same treatment as everybody else inside. Funny little anecdote. If you didn't think it was funny, that's alright. You can just fail the class. I'm kidding. But something to help you remember it if you think that'll help. Let's move on to the covalent compounds. These ones are actually pretty simple. No fancy math really for these ones. The covalent compounds, ladies and gents, are very versatile. They will bind it in many number of ways and give many different types of charges, for instance, like polyatomic ions. And for that reason, we need to use prefixes to determine how many are of each type of nonmetal, or each type of nonmetal in the formula. What that means is you can have something like dinitrogen, which is 2 nitrogens, or you can have pentaphosphorus, which is 5 phosphoruses. The prefixes right here are mono, which is 1, di, which is 2, tri, which is 3, tetra, which is 4, penta is 5, hexa is 6. We typically won't go higher than 6 when we're naming covalent compounds. Let's go over an example. Okay, here is N2O3, and we call that dinitrogen trioxide. Why is it dinitrogen? Well, for one, it's nitrogen. That's pretty obvious. And there's 2 of them there, so it gets the term di based up here. Why do we call it trioxide? Well, obviously it's oxide. There's 3 of them, and so we call it trioxide. Tri for 3. All right. Pretty straightforward, pretty straightforward. Here's something to be cognizant of. The element listed first, in this case right here, is the one who is furthest to the left or furthest from the bottom compared to the second. Okay? So in the case of nitrogen and oxygen, let me put it up here, nitrogen is furthest to the left side, and it's furthest from the bottom, so it gets listed first. It gets priority over oxygen. Let's say we had a case of phosphorus and fluorine. Well, the fluorine or the phosphorus actually would be listed first because it's furthest to the left. Okay, the left takes priority, and then the fluorine would be listed second. Okay. So in such a case, the element listed first is the one who's furthest to the left or furthest from the bottom compared to the second. Also notice the first element doesn't change its suffix, but the second does. Okay, we didn't call this dinitride, we still kept it nitrogen. Right? So whichever one is listed first, its suffix doesn't change. Only the one listed second will change its suffix. Oxygen became oxide. Let's go over an example where we go from the name to the formula. Dihydrogen monoxide. See if you can pause the video and try figuring this one out on your own. Alright, let's go ahead and figure it out together. I always like to start off by writing down the elements that I know that are present. And I know that there is a hydrogen present, voila, and I know there's an oxygen present because oxide. So, now we got to put the numbers with it. Well, di means 2, so there's 2 for nitrogen, and mono means 1. So we don't have to put the 1 there. In fact, you shouldn't put the 1 there. It's implied. So dihydrogen monoxide is H2O. Ladies and gents, what is H2O also known as? It's known as water. You should have known that. If you didn't know that, you should probably read a few books before you join AP Chemistry. Some covalent nomenclature is usually referred to by a common name. In this case, dihydrogen monoxide is just called water. Another example of referring to a covalent compound by its common name is dinitrogen monoxide. Okay, the same one that we had, I believe, on the other page. No, that was a different one. My apologies. Dinitrogen monoxide. Does anybody know what this is called? Dinitrogen monoxide is also known as nitrous oxide. That's the common name for it. This is the stuff they give you at the dentist to make you high as they're about to pull your teeth out. Let's go over another example for formula to name specifically. I have SF6. SF6. Let's write down the name. I know that S is sulfur, and it's listed first, so its suffix doesn't change. And then the second one listed is fluoride. It's fluorine, but it becomes fluoride because it's an ion. Now we have to go in and put the prefixes. For sulfur, there's only one. Now, a lot of you will think to put monosulfur here. You actually don't have to do that. If it's 1 and it's listed and the element is listed first, you can just leave it as sulfur. You don't have to put the mono in front of the first element listed if it's 1. If this were 2, 3, or 4, then it would need a prefix. Fluoride, there are 6 of them. What's the prefix for 6? It's hexa, like a hexagon. Hexafluoride. So this is sulfur hexafluoride. And at the bottom here, I just go into notice that we didn't use mono for sulfur. It's common practice to leave the prefix off if the first element when it is 1 and only 1. Like I said before, if it was S2F6 or S3F6, then we would need to put it. We would need to put a prefix with it. And just to close out, just for your knowledge, sulfur hexafluoride, this does the opposite effect of sucking on helium. You know, if you suck on helium, it makes your voice really high. Well, if you suck on sulfur hexafluoride, it makes your voice very, very deep. I wouldn't recommend doing it a whole lot because it will make you lightheaded just like helium. Alrighty, that is going to close it out for the nomenclature set 7. Please go ahead and do this in the summer assignment. It should be pretty straightforward. And then we'll see you back for section 8.